You're here because you want to master chemical equations with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today.
Next, let's take a look at state symbols. The state symbols, right, in a chemical equation is very important. It indicates the physical state of the particular element or compound, right? So this is usually in solid, liquid, gas, or sometimes aqueous if it's dissolved in water, right? And they're usually put in brackets. So hint, all right, when determining the state symbols, okay, metals are generally solid at room temperature. Ionic compounds are either solid or aqueous, and depending if they are dissolved in water, of course. And our covalent substances, right, generally they can occur in any state. So you kind of need some like background prior information for those covalent compounds. You're kind of seeing a trend here. Now, generally for ionic compounds, right, you want to refer to the solubility table for these ionic compounds to determine the state symbol, right? To determine if it's a solid or it's aqueous, means it's dissolved in water. Okay, so for our solubility table, there are rules that we have to follow, right? And they kind of go in order, right? And you should use this solubility table and memorize it, okay, so that you can easily reference this in your head when you're determining the state symbol for your ionic compounds. For example, your group 1 and ammonium ion, right? Any ionic compound with a group 1 cation, like Na+, okay, or ammonium cation, right? These are all definitely soluble. Same thing for ionic compounds with the nitrate anion, okay? If you have the chlorine or the bromine anion, it really depends what the cation is. Most of it is soluble unless the cation is Ag+ or Pb2+. So for example, right, your AgCl, this is insoluble. Next, we look at our sulfates. Okay, for our sulfates, all are generally soluble except the Lead2+, Ba2+, and calcium2+ cations with them. Okay, so for example, like calcium sulfate, this is insoluble as well. And then lastly, okay, for your carbonates, your hydroxides, and your oxides, these tend to be insoluble, right? Except if you follow like rule number 1 over here, if it has a group 1 or ammonium cation. Okay, so for example, like your calcium carbonate, right? This is generally insoluble. Your calcium hydroxide, your magnesium oxide, these are all generally insoluble ionic compounds, unless it has a group 1 or ammonium ion. So for example, right, sodium oxide. This is soluble in water. Okay, so let's take a look at a certain example over here. So some calcium carbonate powder was allowed to react with dilute hydrochloric acid in a test tube. Okay, so there's a reaction going on over here, and they say effervescence was observed and the temperature change was recorded. A solution of calcium chloride was produced together with water and carbon dioxide. So they already tell you what is produced. And they want you to write the equation with state symbols. Okay, so your job is to write all the reactants and then followed by the products. So the reactants, as they have already mentioned, this is calcium carbonate, right, with hydrochloric acid, and this will give you calcium chloride plus water, okay, plus carbon dioxide, right? And you should be able to determine all these formulas by now based on whatever we ran through beforehand, right? So if you want to determine the state symbols, right, you should determine that calcium carbonate, okay, all carbonates are insoluble generally except if they target rule number 1, unless they have a group 1 cation or ammonium ion, so this is solid. Hydrochloric acid is aqueous, right? We know this because acids are generally aqueous. And calcium chloride is aqueous because most of the chlorides are soluble, and this is one of them. And water is a liquid. This one we just know it by heart, right? And carbon dioxide is a gas. It's also something that you kind of know by heart as well because it's a covalent compound, right? And then make sure to balance the equation, okay? So to balance the equation, which is something we'll run through later as well, right? You just put 2 over here, and this will actually balance the whole thing. Okay, so for balancing chemical equations, for any chemical reaction, right, you must understand that the number of atoms that go in a reaction must equal to the number of atoms that come out from a reaction. Okay, this is what we call the principle of conservation of mass. All right, basically atoms just can't disappear like magic, or they cannot appear out of nowhere, right? Whatever goes into a reaction must come out of the reaction. So the hint, right, is to just not alter the chemical formula during balancing, right? Generally, as you could see from our previous example, you want to always create the chemical formula first and put it all together in the equation first before you start balancing itself, right? Another hint that I always like to teach, right, is that generally you want to start with those formulas, all right, with only one element on each side of the equation. Alright, so let me teach you an example over here. For example, okay, if you look at C3H8 plus O2 to give CO2 plus H2O, okay, so in general, I want to balance the elements first that are only found in one formula on each side of the equation. In this case, you wouldn't want to start with oxygen because it's found here, here, and here, right? There's two on the right side that have oxygen. So I generally don't like to start there, okay? Versus if you look at maybe carbon, right? Carbon is found one on the left and one on the right. So this is a generally good place to start balancing. Okay, so if there's 3 carbons on the left, there's 3 carbons on the right. So you have to put 3 over here. So it's 3 CO2 plus, okay, if you look at hydrogens, right, there's 8 hydrogens on the left. So there must be 8 hydrogens on the right. So you need to put a 4 over here to balance the number of hydrogens. Once you've done that, you can balance the other elements as well. So the element left is just oxygen. Oxygen, right, has, if you calculate everything on the right, there's actually 6 O's from here, 6 O's from here, and 4 O's from here. So there's a total 10 oxygen atoms on the right. So we put a 5 here to balance and make sure that there's 10 oxygens on the left as well. Okay, so let's take a look at some other examples as we go along, and you'll realize that balancing equations is just very easy after going through all this. For example, now you have C4H10 plus O2 to give CO2 and H2O. Same concept. So here I want to start off with carbon and hydrogen. So there's 4 carbons on the left, so I put a 4 over here. And there's 10 hydrogens on the left, so I put a 5 over here to balance the number of hydrogens. Then I count the number of oxygens. There's 8 oxygens here, there's 5 oxygens here. So in total, there should be 13 oxygens on the left as well. Okay, so here I can put a 13 over 2. Okay, you can put improper fractions in your equation. Alright, and this will give you your answer. Now, some schools don't like improper fractions in their equation. Fine. If that is the case, right, and they don't like improper fractions, then you just times 2 to everything. So an alternative answer, right, is you can actually put, right, a 2 and then a 13 over here and then a 8. So you just times 2 to everything and you will get an answer. So the answers in green are alternative answer. Okay, but for the purpose of this video, I will just leave an improper fraction. Your school should be able to accept improper fractions as well. Okay, so let's take a look at the next example. So C4H12 plus O2 to give CO2 plus H2O. Again, let's balance the number of carbons first. 4 here and 6 over here to balance the carbons and hydrogens. Then balance the number of O's. So total there's 8 O's over here and there's 6 O's over here. So there's 14 oxygens altogether. You must put a 7 over here. Next, we look at C3H6 plus O2 to give CO2 plus H2O. So again, same kind of equation, balance the number of carbons and hydrogens first. So there's 3 carbons, so I put 3 over here. There's 6 hydrogens, so I put 3 over here. Count the number of oxygens, there's 6 oxygens here, and then there's 3 oxygens here. So there's total 9 oxygens, so I put a 9 over 2 over here. Right, moving on. C6H12O6 plus O2 to give CO2 plus H2O. Okay, now it's a bit complicated because this first one also has oxygen as well, so just pay attention to that. Otherwise, it's the same thing. C6H12, so there's 6 carbons, so I put 6 over here. There's 12 hydrogens, so I put 6 over here as well to balance the number of hydrogens. And then to balance the number of oxygens, right, there's in total, there's 12 oxygens from here, and there's 6 oxygens from here. So there's 18 oxygens on the right. So remember there's 6 oxygens over here, right? And obviously I do not want to multiply the number of oxygens here by 3 over here because it will influence the carbons and hydrogens. So the easiest way is to edit this value itself. So in that sense, in order to have 18 oxygens on the right, there's 6 oxygens on the left here already, so you need 12 more, so you put 6 over here. Okay, next we have barium chloride plus K2SO4 to give barium sulfate plus KCl. So what I want you to pay attention to is what happens when you have complex ions. Usually when you have complex ions, you want to treat it as a whole. You don't want to count the individual elements because it's too much, right? You don't want to keep track of that many elements. So for example, sulfate, right? You can just put a bracket over here, right? And this SO4 is kind of like 1 unit, right? And you can count the number of SO4s, right? Like for example over here. So this SO4 is already balanced already. You don't have to care about it, okay? What you want to care about is like this potassium over here. There's 2 potassiums. So there's most likely a 2 over here. This 2 will mean there's 2 chlorines, which is balanced over here, and you realize this actually already balances this whole equation very nicely. Okay, next you have calcium oxide plus hydrochloric acid to give calcium chloride and H2O. So you want to most likely balance the calcium first, but this is balanced already, right? And then you want to balance the oxygen, but this is kind of balanced already. So what's left is just the H and the Cl. There's 2 Cls and 2 H on the right, so you just add a 2 over here. Very straightforward. Another example here is copper plus oxygen to give CuO, right? Here it's pretty simple, right? You already have copper that's balanced, right? So you want to balance the number of oxygens. So here there's 2, so you need to have 2 on the right, so there's 2 here. But remember, when you put a number here, it means you're editing the number of copper on the right, so you have to put a 2 as well over here to make sure it's all balanced. Okay, so let's take a look at a few more examples before we move on. So here we have iron plus water to give Fe2O3 plus H2. So again, using the same method, I want to balance the number of iron first, right here, because it's found in one side of each equation. So here you can put a 2 over here to balance the number of iron. Then you want to balance the hydrogen and the oxygen. So here, you want to balance the oxygens. Okay, so you can put a 3 over here to balance the number of oxygens, and then you realize there's 6 hydrogens on the left, so there's a 3 that you have to put over here to make 6 hydrogens on the right. And then in part J, Fe2O3 plus H2 to give Fe plus H2O. You want to balance the number of iron first, that's fine, you can put 2 over here. Then you want to balance the number of oxygens, right? So here, there's 3 oxygens on the left, so there must be 3 oxygens on the right, so you need to put 3 over here. Then you realize that there's 6 hydrogens on the right, so you must put a 3 over here to make it all balanced, so there's 6 hydrogens on the left. Next, part K, okay, there's potassium plus water to give KOH plus H2, right? So you can balance the number of potassium, but that's already balanced, okay? And then you can balance the number of O, but that's already balanced. So the good starting point would be the number of hydrogens, right? Here there's 2H on the left, and then there's actually 3H on the right currently. So to make this all balanced, you can actually put a half over here, and this will make the whole thing balanced already. Next part, we have lithium, right? Plus sulfuric acid to give lithium sulfate and H2 gas. So you want to balance the number of lithium first. You can put 2 over here to make 2 lithiums on the left and right. And then we can look at this complex SO4, right? This is also balanced already, right? You can see there's one SO4 2 minus ion in both sides. So you can balance the number of hydrogens left. So the number of hydrogens, right? There's 2 hydrogens over here and 2 hydrogens over here, so that's also balanced. So this kind of balanced everything already. Then part M, magnesium plus hydrochloric acid, right? To give MgCl2 and H2, you can balance the number of magnesium, but that's already balanced. And then let's look at Cl. Okay, there's 2 Cl, so you put 2 here, then you make sure the hydrogen is balanced, and that's balanced. So that's all you need to do. Okay, then we have N2 plus H2 to give NH3. Here, okay, we can balance the number of nitrogens first, right? So we put 2, and then for number of hydrogens, right, you realize there's 6 hydrogens on the right. So to make this happen, you have to put a 3 in front of the H2. Next, we have part O. So this is NaOH plus H2SO4 to give Na2SO4 and H2O. So I would balance the sodium first. Okay, so there's 2 sodium on the right, so I put 2 over here. Next, you want to balance the sulfate. Okay, so this sulfate ion is already balanced. Then you want to balance the number of O and H's. So just tabulate it up, okay, excluding the ones in the complex ion. So there's 2 O's here, and then there's in total 4 H's in total on the left. Okay, now you compare to the right side. Okay, again, excluding the sulfate anion, right? There's only 1 O and 2 H's over here. So to make this balance, you just need to times 2 to the H2O. Okay, so after going through all these examples, you should be very, very well versed in balancing your equations. Now, what about constructing chemical equations, right? So whenever we have to construct a chemical equation from scratch, right, according to the question, step 1, you need to interpret the chemical reaction first. Alright, so you need to know what reaction is happening, what is reacting with what to give what and what products, right? And some chemical knowledge might be needed as well. Then, step 2, you want to write down the chemical formula of all the reactants and products. So for the formulas, we already learned how to create all of them from what we ran through previously. Then, step 3, you want to balance the equation, then you want to add in any state symbols if necessary, right? So if you follow these 4 steps, right, your equation should most likely be correct. Okay, so let's look at some examples to how we can construct our chemical equation. So let's take a look at this. Gaseous hydrogen and gaseous chlorine combine directly under bright sunlight to produce a third gas, which is hydrogen chloride. So what will help you at the start is to write the word equation first. What reacts with what to give what product. So if you have gaseous hydrogen, so you can just write this down, gaseous hydrogen plus gaseous chlorine, and this will react to give you a third gas, which is just hydrogen chloride gas. Okay, now then you form the chemical equation. So gaseous hydrogen is just H2. We kind of memorize the formula over here, right? Plus gaseous chlorine is Cl2, because this is a diatomic molecule, because this is a halogen, and this will give you hydrogen chloride gas, which is HCl, right? Then you want to balance the equation. So you realize there's 2 H's and 2 Cl's on the left, so we can just put a 2 over here to balance the whole equation. Lastly, if you want to put in the state symbols, then we can just copy the equation and take note of the states, right? So hydrogen, H2, is a gas, so it's gaseous, plus Cl2 is also gaseous, so it's gaseous, and then gives you 2HCl, and this is also gas, so this is in the gaseous state. Okay, let's take a look at another example. So a sample of aluminium foil is allowed to burn in bromine vapor to produce a solid sample of aluminium bromide. So the word equation is just aluminium, you can even write aluminium foil, okay, plus bromine vapor to give solid aluminium bromide. Okay, once we've done that, we can construct the chemical equation. So aluminium foil is just aluminium by itself. Remember, this is just a single element of the metal, so it's just aluminium, plus bromine vapor is a halogen, so it's just Br2, right? It exists as a diatomic molecule, and then this will give you aluminium bromide. Aluminium bromide is an ionic compound, right? So to know the formula, you can write down the ionic charges. So it's Al3+, since this is in group 3 or 13. Bromine is a -1 charge because it's from group 7 or 17. So if you crisscross, you will get aluminium bromide, AlBr3. And then what's left is to balance the equation. So you want to balance the equation. So if you realize there is one Al on the left and one Al on the right, so you want to balance the number of bromine here. So this is just a 3/2. So this will balance the equation. Then you want a chemical equation that still states the symbols. So here, you can just repeat. So this is aluminium foil, so it's a solid, plus bromine vapor, so it's a gas. And this will give you a solid aluminium bromide, which is AlBr3, solid. And this is your full chemical equation. Okay, finally, right, most likely you have to learn how to construct our ionic equations. So there's a couple of steps that we can follow, alright, which is a very foolproof way in order to construct your ionic equations. So step 1, you want to write the balanced chemical equation first. For example, I give you a chemical equation here, CaCl2 plus CuSO4 to give CaSO4 plus CuCl2, and make sure it's balanced, right, and with state symbols. And then after that, your ionic compounds, right, that are in aqueous state, they have to be written as ions. Okay, and you will usually split these ionic compounds up. So for example, calcium chloride is aqueous state, so it's split up into its ionic form, so it's Ca2+ and Cl-. Of course, make sure that it's still balanced, right? So there's 2 chlorine ions, so there's 2 Cl-, right? And then CuSO4 is also aqueous, so it's just Cu2+ and SO4 aqueous, and gives calcium sulfate. This is a solid, right? So we don't need to break this up over here. And then copper 2 chloride is aqueous, so we break it up right here, right? So we break this up. And then after that, you want to remove all the spectator ions. Okay, so you want to know the key players within a reaction, and every type of reaction is a type of key player. Okay, in the simplest way possible, the key players, right, will not be cancelled out. So if you balance this properly, right, you can cancel out any ions, right, that are on the left and right of the whole equation. For example, Cl- you can cancel out, Cu2+ you can cancel out, okay, because they're on both sides of the equation. And then finally, you have your ionic equation, which is actually just Ca2+ aqueous plus SO4 aqueous to give CaSO4 solid. This is actually a precipitation reaction, right? Which is a very common reaction that you will learn, especially when you do QA, right? And the ionic equation is as simple as this actually.
If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.